Hello all. Our project is about experimental characterization of non-uniform corrosion effects on shear strength of participants. Myself, Raja Devarul, and my project mates are John Wilson Samuel and Amitabh Kumar. Also guided by Mr. Hamid, Assistant Professor, Department of Civil Engineering. So let's move on to the introduction part. As we all know, concrete structures are widely employed in civil engineering due to their durability and strength. However, they are not immune to the determined effects of corrosion. So, considering these aspects, we take on our project in the field of non-uniform corrosion and how it is going to affect the shear strength of beams. Also, we have done finite element analysis and we have compared both the results in order to give a proper parametric studies in that field. So, understanding the intricate interplay between corrosion and shear properties is crucial for developing effective mitigation strategies and design guidelines that ensure the long-term safety and reliability of concrete structures.
Problem statement. Corrosion of reinforcement in concrete element is the major factor that affects the durability of RC buildings and RC fixtures. And many of the researchers still assessing it in very prescriptive, but they fail in. They assume that the corrosion is uniform corrosion, but the corrosion is actually not uniform. So considering non-uniform is the need of the day. Also, when the corrosion starts in RC element, the first fiber that is going to affect the tie bars, since it is nearest to the concrete cover. So shear properties are going to affect it, and we are going to study it.
So research there. Till now, researchers have been done by taking the condition of uniform corrosion. Most of the researchers fail to take the condition of non-uniform corrosion, which is actual scenario. So we are taking into account of this research gap. We are going to take the corrosion studies on non-uniform corrosion. So our project objective is to assess the non-uniform corrosion parameters to assess the residual shear strength of the corroded RC.
Methodology. First, we have done the literature study, then gap identification, formulation of objectives, casting and corrosioning of RC beams, corrosion assessment of RC beams, shear capacity check of RC beams, then result and discussion. Finally, manuscript preparation.
So this is work done. So in order to do the finite element analysis, we have to input for the corrosion condition. We have to input certain tested graphs for different levels of corrosion. So for that we have used the prism here. In the prism we have used two set per beam we have used two sets of bar, and we started to corrode using a particular corrosion rate formula. And we have after corroding it, we have tested that particular tensile bar, and we have taken the testing graph and input in the Abacus software. After we have done the finite element analysis, and with the help of this finite element analysis, we have concluded our research by comparing the experimental result as well as the finite element analysis, so that we have used those prisms here. So this is prism beams we have casted. We have used both the epoxy coating as well as the insulation tape at the junction, because when we started the research we have experienced certain junction failures at that particular instant. So we have done with the help of certain insulation parameters at the junction point, and this is our corrosion setup. The beam, the second picture indicates after the corrosion. So with this we have even taken the crack properties, and after that we have deepened that concrete layer surrounding the bar, and we have done the tensile test. So this is a detailing of our shear beam. This is a corrosion setup which is done using the DC power supply, and from that we can infer the voltage fluctuation as the time moves on.
One beam among the 1.2 meter beams that are subject to accelerated corrosion were taken out of the test tank, and testing is done. We have done the surface resistivity test using reciprocal surface resistivity meter, and we have arrived the results.
So this is the result we have done from half cell potential test. It's conducted using the device called half cell potential meter for the control beam as well as 30 percentage corroded beam. It is a non-destructive method.
So we have taken two types of entity, that is one is surface resistivity and the another one is offset protection. Here many of them have not interpreted both the results at a similar manner, but we have concluded we have interpreted both the surface resistivity results as well as the one which we get from the half cell potential meter test, and from which we can conclude that the probability of corrosion increases as surface resistivity of the concrete decreases. So this is our experimental setup when we are going when we have done the testing. And the ultimate load of 30% corroded beam is 18.15 tons, and the ultimate load carried by the 40% corroded beam was 16.87 tons. For both the beams, the failing happened through the occurrence of shear cracks, because when we induce accelerated corrosion in those beams, we have taken a wire inside the from the beams, and the wire is directly connected with the stirrups. So from which we can conclude that we have intentionally corroded the stirrups. So as we aim, we achieved the shear crack, and through the occurrence of shear crack, we achieved the shear failure.
So this is the result. Found a finite element analysis done for the 30% corroded beam, and it is compared with experimental results, from which we can infer that both of the finite element analysis and experimental results are 98% correlating with each other.
This is the experimental load strain graph of 30% corrode beam. This is plotted by using the T-Mach gauge reading, which is a strain reading, from which we can infer that the strain at compression zone and tension zone are inversely proportional to each other.
So this is a finite element analysis which we have done using the Apache software, and for the control beam is also done, and we have compared all the different levels of corrosion beams with the control beam. So thank you.
Thank you.